Hey there, thank you for tuning into CMTEQ channel. In this tutorial, we're going to compare the RDS on resistance of 4 different type of MOSFET I've got here with me, and one of them is the very famous IRF 840, which is the N-channel MOSFET. Now, why are we choosing to compare the RDS on resistance? Well, this is a very key parameter for a MOSFET. That is why they actually listing it here as a second parameter in the product summary, because it's so crucial that if the RDS on resistance is high, then your system is going to be very inefficient, right? So these RDS on resistance speak of the system efficiency. Now, especially because most of the time we are using MOSFET as switches, right? Now, I've got a switch here. When I'm switching here, if I want to let a high current through this switch here, I will have to rely on a very low contact resistance of this switch so that my system is going to be very efficient. There won't be a lot of losses. But if the contact resistance here is high, that means I'm going to have high power dissipation to the switch, and that's going to result in losses. Most of the time when we are using a MOSFET as a switch, okay, we are basically applying a 5-volt signal here on VGS, and that basically will turn our switch on and allow IDS, right, the current to flow from the drain to the source to drive our loads. Okay, now if you look at the parameters here, they're stating that our RDS on for this IRF MOSFET is 0.85. Okay, so it's basically less than 1 ohm when VGS is 10 volts. So when VGS is 10 volts, so you apply a voltage between the gate and the source that is equal to 10 volt. That's a test condition that will give you this RDS on resistance. Now, this is not the case when you apply 5 volt here, because your 5 volt is coming from your Arduino or from your STM32 microcontroller or from any other embedded system device that you are using. So that will give you a 5 volt or even sometime a 3.3 volt. Then you need to do some level shifting to get maybe a 5 volt. Okay, now having said that, the point here is if you've got a 5 volt that is now applied at the gate of this MOSFET here, with your 5 volt signal applied here at the gate, you basically not meeting the 10 volt test conditions to get that lowest RDS on. So what you are doing is you merely basically just reaching the threshold voltage to basically turn the MOSFET on. Now let's look at the threshold voltage for this MOSFET here. VGS threshold. Okay, so it's the minimum is 2 volt and the maximum is 4 volts. So which means as soon as you go above 4 volt, this MOSFET is going to be turned on. That's a threshold, but it's not going to be fully turned on for you to get the lowest RDS on possible for that MOSFET so that your system can be efficient. Now, because now we're working on MOSFET as a switch, right? Which means we're not going to get that 10 volt apply onto our MOSFET, except if you design your circuits to get you a 10 volt on the gate of your MOSFET. But now let's assume that we are switching this MOSFET with a 5 volt. So what will be the value of our RDS on when we apply a signal of just about 4 volt to turn on, to partially turn on this MOSFET? So in this tutorial, that's basically what we're going to compare. The RDS on of these 4 different MOSFET here under very similar test conditions here, because I've got two 10K resistors here. Okay, so these 2 resistors, I'm basically just setting up the voltage divider between these 2. So which means if I apply a 10 volt signal here, I'm going to get a 5 volt, and the 10 volt is going to be available to drive my load here at the drain. Okay, and that's going to result in this MOSFET or any one of these MOSFET being partially on, not fully on for the 10 volt. Okay, so what will be that RDS on resistance when this MOSFET will be partially on? That's what we're going to compare. And remember, the value of that RDS on will tell you how hot this MOSFET is going to get. Now, let's say you got an RDS on resistance of 2 ohm for this MOSFET here. Now you got 2 ohm and there is 1 amp flowing RDS. That basically means you're gonna have 2 watt burning across the MOSFET. So 2 watt being wasted there on your MOSFET. So you're going to basically need a heat sink so that your MOSFET doesn't get overheated. First one is here, the TK100E08. So with an RDS on of 2.6 milliohm, typically, right, at VGS is 10 volt. And the next one will be this one, the FQ-A9N. So that a high voltage MOSFET here, and that got the RDS on of 1.4 ohm, also at 10 volt VGS. Then this giant here got a small RDS on as well of 89 milliohm. Okay, so now we've got this MOSFET here. We can basically connect them to this circuit already made, and the test conditions are going to be very similar, and we're going to measure VDS, right? That's what we need to basically calculate RDS on. Okay, but before we do that, please, if you find this tutorial useful, make sure you subscribe to CMTEQ channel and give this tutorial a thumbs up. Turn the notification on so that you don't miss tutorial of this nature when they are uploaded. I thank you so very much. So I'm going to basically put in the formula here. First, the formula to get RDS on. So we know that VDS here is basically equal to ID, right? So IDS, that's the drain to source current this way. Okay, down here, that's the same current, and that multiply with the resistance here. Okay, so that's going to be RDS on. So that's our resistance that we are after. Okay, so now to get RDS on here, we basically have to divide VDS divided by IDS. Okay, so that's going to give us a value of RDS. Okay, so we have to measure VDS, and once we got RDS on, we can basically know how much heat is being dissipated between these MOSFET transistors, and in that we can calculate the power dissipation simply by doing RDS, right? RDS times IDS square. Okay, so that basically going to give us the power that's being wasted across the MOSFET when we try to run this big load here. Right, so I've got my MOSFET in, the first one, the TK100E on our list here. So I'm going to turn the circuit on and basically applying my voltage between V plus and V minus. So I turn the circuit on. I've got 7 volt there right now, which means I'm expecting to have a 3.5 voltage here at this point here. Okay, so let's go ahead and measure it. Okay, and we're going to ground and gate. Okay, ground and gate, we're getting 3.5 volt. Okay, so that basically means this MOSFET is not on yet, because what is the threshold for this MOSFET? So the threshold for this MOSFET is 4 volt. V threshold is 4 volt. So which means at 3.5, the MOSFET is not yet on. So I'm going to increase the voltage here to go all the way to 8 volt. Right, as soon as I reach 8 volt, okay, so let's measure it. As you can see, we've got 7.8, basically 7.8, and here we got 3.9. so that's kind of good enough to already turn on this MOSFET. So I'm going to go ahead to over 10 volt so that we can get a 5 volt here. So that's our chosen test condition. We want to get a VGS of 5 volt for all the test conditions here. Great, so I've got 5.1 volt. Now with 5.1 volt, I'm already recording on my power supply here. A 1 amp current is flowing. IDS is 1 amp. So let's go ahead and measure VDS. Okay, so we need to measure VDS of this MOSFET. So when we measure VDS of this MOSFET, I'm getting, as you can see there, 0.014. So that's about 14 millivolt. right? 14 millivolt for this MOSFET. And I can tell you right now, this is already getting very hot and the MOSFET is very cold. Right, as you can see here, 11.13 watt through this MOSFET, and IDS is 1 amp. Okay, and as we already measured here, we've seen that the voltage between the drain and the source is 0,014 volt. So that is basically 14 millivolt across drain and source for this MOSFET, with VGS equal to 5 volt and IDS is 1 amp. So now we can go ahead and calculate our RDS on for this MOSFET. So as per our results here, we know that we got VDS was equal to 0,014 volt. Then we also measure the current IDS of 1,04 amp. Now with this test result, based on this formula that we've got here, we also calculated an RDS on equal to 13,46 milliohm. Right, that is why this transistor, this MOSFET was running very cold, okay, while I was driving over 10 watt, 11 watt loads on it, and it was running pretty cool. Now, when we go back to the data sheet of this MOSFET here, and we can see that they say that it has an RDS on of 2.6 milliohm at VGS 10 volt. Now, this is with VGS equal to 5 volt, we're getting 13.46 milliohm. So we can clearly see that if we move all the way to fully turn it on at 10 volt VGS, we are more likely to get close to that 2.6 or maybe a 3 or 4 milliohm resistance. So which is pretty much they are telling the truth right there. So if you respect all the test conditions, you are most likely to get that value. Right, now let's go ahead and move on to the next one, which is a very famous one, IRF 840. Right, so now let's go ahead with our second one. So that's the IRF 840. Okay, so I'm going to turn on the circuit. Right, 10 volt already applied, so the MOSFET is already fully turned on. As we can see, the voltage is 10.6. As per our voltage divider, we know that VGS is already at 5 volt. Now you can see that the current here is 0.93 amps, and I've got a load of 9.8 watt. Okay, now let's go ahead and do some measurement here for this MOSFET. So with IDS here equal to 0.93, I'm getting a VDS of 1.13. So let's go ahead and confirm the value of VDS here. So let's just turn this on. Then we can confirm the value of VDS. As you can see, it's 0.08. Okay, 0.08. At the time I measured it, it was 0.13, but you get a picture. So 1.1 volt. So that's the value of VDS at this current. So we can go ahead and calculate our RDS on for this MOSFET. So let's go ahead and turn this off. So basically with these parameters, we found the value of RDS on equal to 1,18 ohm. So that is very close, slightly high, because this, as we know, it's at VGS equal to 10 volts. So if we fully turn this IRF MOSFET on, we should be getting a value closer to 0.85. At this resistance value with 1 amp, you can expect this MOSFET to basically start getting hot. Okay, so which means if you are using this for an on-off switch, make sure that you have a heat sink applied to this MOSFET, because it is going to get quite hot with this high RDS on resistance, compared to the first one that we did here with the 13.46 milliohm of RDS on value. Now let's move on to the third one on our list here. So that is a high voltage 900 volt 9 amp MOSFET. and this one with a 1.4 ohm RDS on resistance. So let's go ahead and quickly replace it into our circuit here. There we go. Great. So now, let's go ahead and turn on the power, right? So the MOSFET is fully on, so we can go ahead and measure VGS. That is important to us. So it's 5.1. Okay, similar test condition. And the voltage between the drain and the source is sitting at 1.9 volt. Okay, so this MOSFET, what is it? It's a FQA9N90, right? So VDS here we are getting equal to, let's just confirm that value once again, it's 2 volt now. So it's 2 volt, and IDS I'm looking at 0.84 amps. So with these parameters we can calculate the value of RDS on, and I'm getting a value of RDS on is equal to 2.38 ohm basically. Okay, so this is less than an amp running. So with a value of 2.38 at 5 volt, you can see the test condition. Now remember, this test condition here of 1.4 ohm is at 9 amps. So this is a high voltage MOSFET. So we only driving it at 1 amp at 10 volt on the drain. So this MOSFET needs a much higher voltage so that you can meet those test conditions, but you get the picture. Okay, so if I feel it, you can see it's getting slightly hot because now there is about almost 2 watt of power being burned through the MOSFET. Now you have to use a heat sink. Now let's go ahead and test the last MOSFET on our list here. So this is also a high voltage MOSFET, but this particular one got a very small RDS on compared to this one. So let's go ahead and plug the last MOSFET here on our list. So VGS. Okay, so gate drain source. Now these MOSFET have been connected. Okay, so we can go ahead and power the circuit. Our load is still hot here because the previous MOSFET was driving it. Now if I turn on this circuit once again, as you can see, the MOSFET is turned on because I've already got a 10 volt running there. So we can go ahead and measure VGS, and VGS is 5.2. okay, so the MOSFET is turned on, but it's not fully turned on because the test conditions is also for a 10 volt VGS. Right, so we can see here the drain source on state resistance is typically it's 89 milliohm as we've seen on the front page parameters, but the maximum is 109 milliohm. So this is for VGS equal to 10 volt. Okay, so now we're applying a 5 volt VGS and we got a much smaller current because this is a high voltage MOSFET as well. So when I feel it, it's not yet getting hot. It's slightly warming up because now we are driving a load on it. And when I measure here, we're getting a 4 volt here. VDS across his MOSFET here. So he is not very happy with what we are doing. Let me feel it again, and it's getting hot. So this is a high voltage. This high voltage MOSFET, you have to run them at a higher voltage, and so you can meet all the test conditions. So running it at a lower voltage is not going to satisfy your situation. But obviously, if you are using a MOSFET as a switch, you know exactly what type of load you are switching. So if you are switching a high voltage load, then you're gonna run a high voltage MOSFET. If it's a low voltage load, then you're also going to have a low voltage MOSFET. So the takeaway for this tutorial is simple. If you're going to use a MOSFET as a switch, right, you're not going to turn it on with a 10 volt VGS. Please make sure you consider the RDS on at that point, because that is going to determine how hot your MOSFET is going to run, and over a long term it's going to affect its lifespan and also the efficiency of your system. So ensure that you got a MOSFET with the smallest RDS on as possible, like this one here, the TK100E, which has a RDS on of 2.6 milliohm. And that way, with your 5-volt VGS, you always going to be okay. Your MOSFET is going to run very cold. You won't even need a heat sink for that particular one. Okay, and if you're going to switch it on with a 10-volt VGS, then also ensure that you know what is your RDS on and how much heat will be dissipating through that resistance, through the MOSFET at a specific value of a current. So that is it, guys, for this tutorial. We're going to stop it here before it gets too long. So if you find it useful and you would like to see more tutorial like this, please subscribe to CMTEQ channel, and also don't forget to give it a thumbs up. Until next time, cheers.